Hello, Namaste, Konnichiwa. Welcome to Sunny Sensei. In this lesson, we are going to prove an interesting trigonometric identity. Sec A plus tan A whole square equals 1 plus sin A over 1 minus sin A. As always, before we dive into the proof, pause the video, take a few minutes and try it on your own. Alright, I will start with the left hand side. Sec A plus tan A whole square. But why the left hand side? Well, you are actually free to start from either side, left hand side or right hand side. In this case, I see sec and tan, which are secondary functions, on the left hand side, and sine, a primary function, on the right hand side. It's usually easier to simplify secondary functions into primary ones like sine and cos. So I picked the left hand side as my starting point. Now over here, sec A is 1 by cos A and tan A is sin A by cos A. Since both terms have the common denominator, we can combine them over a common denominator, cos A. So we get open bracket 1 plus sin A divided by cos A close bracket whole square. This simplifies to 1 plus sin A whole square divided by cos square A. Now, how do we proceed from here? Look at our target, the right hand side. It has only sin A and no cos A. That's a hint. We need to eliminate cos square A. And we do that using this fundamental trigonometric identity. Sin square A plus cos square A equals 1. So, cos square A becomes 1 minus sin square A. The numerator is still 1 plus sin A whole square. And the denominator becomes 1 minus sin square A. What next? That 1 in the denominator can be written as 1 square. Same value, but this helps us spot a pattern. 1 square minus sin square A reminds me of this algebraic identity. A square minus B square equals A minus B, A plus B. We apply that here and replace 1 square minus sin square A with 1 minus sin A times 1 plus sin A. One plus sin A is common in both numerator and denominator. We cancel out the common factor and we are left with 1 plus sin A over 1 minus sin A. And that is exactly our right hand side. And with this, we have successfully proven this identity. But hold on, let's challenge ourselves a bit more. This time, we will prove the same identity again, but with a slight twist. Our starting point will be the right hand side. Yes, this extra bit of practice is definitely good for you. And once again, pause the video and give this challenge a try before you look at the solution. Alright, we start with the right hand side. 1 plus sin A over 1 minus sin A. Now, how do we proceed? The key to solving any identity is to always keep an eye on the target. Since we started with the right hand side, our target is the other side, the left hand side. A quick scan tells me if I divide both the numerator and the denominator by cos A, I might get closer to the left hand side. So let's go ahead and do that. We divide both the numerator and the denominator by cos A, and we get 1 plus sin A divided by cos A over 1 minus sin A divided by cos A. Now let's simplify this. The numerator becomes 1 by cos A plus sin A by cos A. The denominator becomes 1 by cos A minus sin A by cos A. 1 by cos A is sec A and sin A by cos A is tan A. So now we have sec A plus tan A over sec A minus tan A. What do we do next? One more look at the target, the left hand side, tells me that we need sec A plus tan A whole square in the numerator. We already have sec A plus tan A in the numerator. So let's multiply both the numerator and the denominator by sec A plus tan A. The numerator now becomes sec A plus tan A whole square, exactly what we want. And the denominator, now it is sec A minus tan A times sec A plus tan A, which is another identity. A square minus B square equals A minus B, A plus B. So the denominator becomes sec square A minus tan square A. Now recall this basic identity. Tan square A plus 1 equals sec square A. This means sec square A minus tan square A equals 1. So our numerator is sec A plus tan A whole square, and our denominator is just 1. This gives us sec A plus tan A whole square, which is our left hand side. And we are done. We have proven the same identity again, starting from the right hand side. If you enjoyed this lesson, don't forget to like, share and subscribe to Sunny Sensei. Thank you and see you again soon.